You were taught physics as a collection of facts, laws to memorize, formulas to apply, problems to solve by following steps that someone else already decided were important. You were told that understanding physics meant knowing the right equations and getting the right answers. That teaching failed you, not because the equations were wrong, but because the method was. Feynman didn't teach physics the way most people do because he wasn't trying to transfer information. He was trying to correct the way you think about reality. That difference is everything. Most physics education starts with results. Newton's laws, Maxwell's equations, conservation laws. You are shown what works, then trained to use it. The underlying reasoning is treated like a historical curiosity. Feynman did the opposite. He started by dismantling your assumptions. He knew that the biggest obstacle to understanding physics is not ignorance. It's confidence in the wrong picture. You come in already believing you know what force is, what motion is, what cause and effect are supposed to look like. Physics has to unteach you before it can teach you. That's why people say Feynman makes physics feel different, not easier, different. He doesn't give you answers to hold on to. He takes away the questions you never should have been asking. Most explanations try to make physics intuitive by leaning on everyday experience. Feynman did not trust that instinct. He knew everyday experience is a terrible guide to how the universe actually works. Your intuition evolved to throw rocks, not to understand fields. So instead of asking, "How do I make this feel familiar?" he asked, "What is the simplest description that actually works?" That simplicity is why his explanations feel shocking. They strip away the metaphors you didn't realize you were leaning on. Take force. You were taught that force causes motion. Push something, it moves. Pull something, it accelerates. That story feels obvious until you ask what a force really is. Feynman didn't let that slide. He pointed out that force is not an explanation. It's a description. Saying something moves because of a force is just restating the observation in different words. The real content of physics is not naming things, it's discovering relationships. Feynman taught physics as a search for invariance, quantities that stay the same no matter how the situation changes. Energy, momentum, charge, symmetry. Those are not things you can picture, and that's the point. You never understood physics the way Feynman teaches it because you were trained to expect pictures where only rules exist. Most teachers give you analogies: springs, balls, waves on strings. Those analogies are scaffolding, but they become dangerous when you forget they're temporary. Feynman tore the scaffolding down as soon as it stopped being useful. That's why he was willing to say things like, "Energy is just a number," not because he was being dismissive, but because he was being precise. Energy is not a substance. It is not stored like fuel. It is a bookkeeping quantity that stays conserved. Once you see that, half of your confusion disappears. The same with light. Most explanations bounce between wave and particle, as if the universe is undecided. Feynman showed that this language is the mistake. Light is not confused, you are. The theory works perfectly without deciding what light really is. The demand that it must be one thing or another is a human demand, not a physical one. This is the pattern in everything Feynman taught. He didn't try to answer metaphysical questions. He showed you which questions were meaningless. That is why people feel like they finally understand physics when listening to him. Even when the material is advanced, he is not adding complexity, he is removing it. Most teaching adds layers. Feynman removes assumptions. This is also why his explanations feel unsettling. They don't let you rest on familiar ground. They force you to accept that reality does not owe you a comfortable picture. Physics is not about what you can imagine. It's about what the universe does. And the universe does not behave the way common sense expects. You were taught physics as a story about objects moving through space. Feynman taught physics as a story about constraints, about what can happen and what cannot. Regardless of how badly you want a picture, that shift is why you've never understood physics the way he teaches it. Not because you weren't smart enough, because no one told you that understanding physics means letting go of the need to understand it in the old way. Most explanations try to protect you from confusion. They smooth over the rough edges. They replace difficult ideas with friendly pictures and hope you don't notice what was lost in translation. Feynman did the opposite. He was willing to let you be confused for the right reason. He knew that confusion is not the enemy of understanding. False clarity is. When you are given a neat picture too early, you stop asking questions. You think you understand, but what you really have is a metaphor that only works in a narrow range. The moment you step outside that range, everything breaks. Feynman didn't want you to feel comfortable. He wanted you to be honest. That's why he kept saying things that sounded almost dismissive. Nobody understands quantum mechanics. Energy is just a number. Nature isn't classical, damn it. He wasn't being flippant. He was cutting away expectations that had no right to be there. Take explanation itself. Most people think explaining something means telling a causal story. This happened because that happened, which caused something else. A chain you can picture. Physics does not work that way at the deepest level. At the deepest level, physics tells you what relationships exist and which quantities remain invariant. It tells you what changes and what cannot change, no matter how you look at the system. That's not a story, it's a structure. Feynman understood that if you insist on turning structure into story, you will misunderstand the structure every time. This is why he was obsessed with symmetries. Symmetry is not something you see, it is something you infer. It tells you that the universe behaves the same way even when you change your perspective. Rotate the system, shift it in time, move it through space. Some things stay the same. Those things are what matter. Energy exists because the laws of physics don't change over time. Momentum exists because the laws don't change from place to place. Angular momentum exists because the laws don't care which way you face. That is physics, not forces pushing objects around, but constraints that refuse to be violated. Most teaching starts with forces because forces are intuitive. Pushes and pulls feel real, but forces are not fundamental explanations. They are convenient summaries of deeper regularities. Feynman never let you forget that. When he talked about gravity, he didn't dwell on falling apples. He went straight to the uncomfortable truth that gravity is not a force at all in the usual sense. It's geometry, curvature, structure. That is not easier to imagine. It is more accurate, and accuracy mattered more to him than comfort. This is why his explanations feel so different. He wasn't trying to make physics fit into your existing mental furniture. He was asking you to throw the furniture out. You don't learn physics by adding ideas. You learn it by subtracting bad ones. Most people never get that lesson. They learn how to solve problems, but not how to think physically. They can calculate answers without knowing what those answers mean. Or worse, thinking they mean something they don't. Feynman attacked that directly. He insisted that if you can't explain something clearly, you don't understand it. But clearly did not mean with a picture. It meant without lying. If the honest explanation is abstract, then the explanation should stay abstract. This is why he was comfortable saying things like, I can tell you how to calculate it, but I can't tell you how to imagine it. That wasn't a failure. That was the point. You were never meant to imagine everything. The universe does not arrange itself around the limits of your intuition. Once you see that, a strange thing happens. Physics stops feeling like a collection of disconnected topics and starts feeling like one continuous idea. Energy, momentum, light, matter, fields, quantum mechanics. They are not separate chapters. They are different faces of the same discipline, a discipline that cares about what stays the same when everything else changes. Feynman taught you to look for that sameness, instead of chasing mechanisms that don't exist. That is why people who listen to him feel like something clicked, even if they can't immediately solve more equations. Their mental posture changed. They stopped asking, what is it made of? They started asking, what relationships are being preserved? That shift is why you've never understood physics the way Feynman teaches it. You were trained to collect answers. He trained you to dismantle questions. And until you make that shift, physics will always feel like a foreign language you can speak, but not think in. Feynman never started with authority. He didn't ask you to believe him because he was right. He asked you to follow the logic and see where it failed if you try to cheat. That's why his explanations feel alive. He constantly tested ideas against reality, not against tradition, not against textbooks, against what the universe actually does. Most teaching tells you, this is the law. Feynman asked, what would break if this weren't true? That question changes everything. It forces you to see physics as a living constraint system, instead of a frozen list of results. Laws are not commandments. They are summaries of what has survived every attempt to violate them. This is also why he emphasized experiment so relentlessly, not as decoration, but as the final judge. You don't understand physics because you've memorized equations. You understand physics when you know which equations are allowed to exist at all. That difference is subtle and brutal. Take conservation laws again, because this is where Feynman quietly rewired how people think. Most students learn conservation as a rule to apply after the fact. Solve the problem, then check if energy is conserved. Feynman flipped that logic. Energy conservation is not something that happens. It is something that forbids other things from happening. That makes it foundational. If you understand that, physics stops being reactive and becomes predictive. You don't ask what happened. You ask what is impossible. That's how Feynman thought. He didn't look at nature and ask for stories. He looked for impossibilities. And wherever impossibility showed up consistently, there was a law. This is why his teaching feels so sharp. It is always cutting away at what cannot be true. Most teaching adds layers of explanation. Feynman removes layers of misconception. And that removal feels like insight. He also refused to hide uncertainty. If something could not be explained in familiar terms, he said so. He didn't invent metaphors to make himself look helpful. That honesty is rare. When he said nobody understands quantum mechanics, he wasn't mocking you. He was warning you not to mistake comfort for understanding. Understanding, in his sense, meant knowing where the theory works, where it doesn't pretend to work, and why that boundary exists. That boundary awareness is what most people never develop. They learn how to compute without knowing what the computation means. They learn how to talk without knowing what is real. Feynman insisted on separating those. He showed you that physics is not about finding the right picture. It's about knowing when pictures stop being legal. Once you see that, you stop feeling betrayed when physics refuses to explain something the way you want. You stop asking for more than the universe is willing to give. And that is where understanding begins. This is also why Feynman's explanations age so well. They don't depend on specific discoveries, they depend on method. He was teaching you how to think, not what to memorize. That's why people who listen to him decades later still feel like something has shifted. The equations may change, the constants may be refined. The thinking does not. Physics taught this way stops being intimidating, not because it's easier, but because it's honest. You know where the ground is solid and where it isn't. You know which questions are meaningful and which are decorative. Most people never get that map. They get answers without orientation. Feynman gave you orientation. He taught you that the universe is not obligated to explain itself in human terms, and that the job of physics is not to force it to, but to listen carefully to what it allows. That's why you've never understood physics the way Feynman can teach it. Not because you lacked intelligence, because no one told you that understanding physics means accepting that the universe speaks a different language than intuition. And once you accept that, physics stops being a wall of formulas and starts being a conversation with reality itself. At the end of all this, the reason Feynman teaches physics differently becomes almost uncomfortable in its simplicity. He never tried to make physics feel understandable. He tried to make it honest. Most teaching is designed to make you feel progress, to give you the sense that you're accumulating understanding step by step, like stacking bricks. That feels good. It also hides the fact that many of those bricks don't actually support anything. Feynman refused to build that way. He was willing to tear the structure down if the foundation was wrong, and that is why his explanations feel sharper than anyone else's. They are not padded. They are not optimized for reassurance. They are optimized for contact with reality. You've never understood physics the way he teaches it because you were trained to expect physics to answer questions in a human way, to tell you what things are, what they're made of, what's really happening behind the scenes. Physics does not do that. Physics tells you what cannot happen. It tells you what must remain unchanged. It tells you what relationships survive every experiment. Everything else is decoration. Feynman understood that the deepest ideas in physics are not objects or mechanisms, but constraints, symmetries, invariances, patterns that refuse to break no matter how hard you try. Once you see that, the subject stops being fragmented. Quantum mechanics is not about tiny particles doing weird things. It is about probability constrained by symmetry. Relativity is not about fast objects and slow clocks. It is about the structure of space-time refusing to privilege any frame. Energy is not a thing that flows. It is a number that stays balanced because time behaves consistently. Gravity is not a force pulling you down. It is geometry removing alternatives. These are not poetic rephrasings. They are corrections. And they all share the same teaching method. Remove the picture. Keep the rule. That's why Feynman's explanations don't age. Pictures expire. Rules don't. This is also why people often feel unsettled after listening to him. He doesn't leave you with a warm sense of mastery. He leaves you with a sharper sense of where mastery ends. He teaches you how to know when you don't understand something and why that's not a failure. Most education hides uncertainty behind authority. Feynman exposed uncertainty as part of the structure. not uncertainty in prediction, uncertainty in description. And once you accept that, a strange calm sets in. You stop fighting physics for not being intuitive. You stop demanding it explain itself in stories. You start meeting it on its own terms. That is the moment when physics actually becomes understandable. Not because it suddenly makes sense in your head, but because you stop trying to make it make sense in the wrong way. You stop asking, what is really happening? You start asking, what must be true for this to work? That shift is everything. Feynman didn't give people better answers. He gave them better questions. And more importantly, he showed them which questions to abandon. Once you see physics this way, the subject stops feeling like a wall you have to climb and starts feeling like a landscape with clear boundaries. You know where the ground is firm. You know where intuition fails. You know where calculation takes over. That clarity is rare, and it is why you've never understood physics the way Feynman can teach it. Not because you weren't capable, but because no one told you that understanding physics means accepting that the universe is under no obligation to be explainable in human terms. It only has to be consistent. And it is.